Hi everyone, my name is Devon. I am a senior at Harvey Mudd College, and today I will be telling you all about Braitenberg vehicles. But before we get into that, I have a question for you all. What do you think of when you think of the phrase artificial intelligence? I'm guessing that a lot of you are thinking of this. And if not this, maybe one of these. Nowadays, large language models and generative AI are all the rage. But it didn't used to be this way. In fact, not so long ago, when people thought of artificial intelligence, they thought of this. This is a picture of Google's AlphaGo defeating world Go champion Ke Jie in a game of Go in 2017. And before that, when people thought of artificial intelligence, they thought of this. This is a picture of IBM's Watson defeating Jeopardy champions Ken Jennings and Brad Rutter in a game of Jeopardy in 2011. So, what do all of these AIs have in common? Well, it's complicated. Like, seriously, what they have in common is that they are all very complicated. For example, ChatGPT is said to have 1.8 trillion parameters, and IBM's Watson was a room-sized supercomputer with thousands of processors running millions of lines of code, taking 85,000 watts of power. With that much power, I feel like it was really a missed naming opportunity for IBM not to call it IBM Watson with 2 T's. Okay, anyways. What if I told you you didn't need trillions of parameters or 85,000 watts in order to have artificial intelligence? What if I told you that all it took were a few simple components and then you could have human-like behavior? Well, this is precisely what Valentino Braitenberg argues in his 1986 book, Vehicles, Experiments in Synthetic Psychology. In this book, Braitenberg describes a series of thought experiments centered around this concept of a vehicle. So a vehicle is made out of sensors and motors and interacts with stimuli generated by sources in the environment. And according to Braitenberg, that's all you need for human-like behavior. So now I'm going to give a brief description of how it generally works. So to the right, we have pictured a source which generates stimuli. That stimuli is then received by the sensor, which passes it as input into the motor. The motor then propels the vehicle forward. Now, this very simple vehicle with just one sensor and one motor is precisely vehicle 1, which Braitenberg calls alive. So we can sort of imagine that vehicle 1 has speed proportional to the stimuli in its environment. But don't just take my word for it, let's see it in action. So back then, all we had were sort of Braitenberg's thoughts and his book, but thanks to modern technology, we are now able to visualize the vehicle behavior described in his book. So this is a simulator I made with some other Harvey Mudd College students. I'll just give a brief overview so far. So this top part here, we have some descriptions, controls here, so we can play and pause the simulator, zoom in and out, control the vehicle speed. And then this panel here helps us manage the sources, and this panel here helps us manage the vehicles. Now, in the interest of time, I've already done some setup here. So I just have one source over here to demonstrate some basic behavior, and I have in sort of arena setup for some more interesting things. So with vehicle 1, we can see that as it gets closer to the source, it gets faster, and then as it gets further away, it becomes slower. So this is not very interesting, so I'm gonna move on to the next one. So vehicle 2 each has 2 sensors and 2 motors, with vehicle 2A having straight connections. So we can sort of imagine here, in the picture, the right sensor is closer to the source, meaning that the right motor will push more, causing it to sort of go away from the source. So Braitenberg calls this the coward. And then in the picture on the right, we have cross connections. So here the right sensor is closer to the source, meaning that the left motor will push more. So the vehicle will sort of go towards the source in an attacking motion, and Braitenberg calls this aggressive. So let's see what it looks like in the simulator. I'm gonna do the aggressive vehicle first. See, it looks like this. And what this reminds me of is those telemarketers or scam callers who just won't leave you alone. And I think the thing that really reminds me of this is you think that they're kind of going away for a while, but then they just like come back to spam you with calls about your extended car warranty or something. So yeah, this is the aggressive vehicle. I'll put some more in here. And then the coward vehicle, this is the vehicle that I personally relate to a lot because I'm the kind of person who doesn't pick up unknown phone numbers. So the spam callers will never get me. So yeah. Okay, now let's look at vehicle 3. So to understand vehicle 3, we must introduce a new component called the inhibitor. So the thing to remember about the inhibitor is the inhibitor inverts the relationship between sensor input and motor output. What this means is that before we had more sensor input equals more motor output, and now we just have sort of the opposite. So more sensor input means less motor output. Again, we have two types of vehicle 3, 3A with straight connections and 3B with cross connections. So 3A is sort of just going to go up to the source and stay there, and Braitenberg calls this love. And 3B, it's also going to go up close to the source, but then when it gets really close, it's sort of just gonna shoot off. So let's see what this looks like. I'm gonna remove these other vehicles. Okay, so this is 3A, which is love. Oh, that was too far. Okay, so we see it sort of stays at the source here. You know, I think I love my friends, but it doesn't really look like this. What this actually reminds me of is during the pandemic, I binge watched the entirety of Avatar: The Last Airbender. And so I was kind of just like sitting at my TV like this. And according to Braitenberg, that's love. So, and Explorer, so we can see Explorer is similar to love in that it goes up really close, but then it sort of shoots off. And it's also similar to the Coward in the sense that it moves away from the source, but it's different because the Coward just sort of constantly moves away, but this actually goes up close to it and then moves away. So unfortunately, these little explorers are trapped in this arena. That's kind of sad. But what this reminds me of is, you know, trying like exploring some new food, and then I don't really like it. Like I try it for the first time, and then I'm like, nope, don't like celery. Yeah, that's the vehicles 3A and 3B. And for vehicle 4, I need to introduce an abstraction of some concepts we've seen earlier. So if we let x equal the sensor input and f of x equal the motor output, then just a sensor connected to a motor will have the equation f of x equals x. Motor output equals sensor input. If we have an inhibitor, we're gonna have something like f of x equals 1 over x, just inverting that relationship. Then for vehicle 4, what we have is f of x is equal to some function g of x. And if g of x is differentiable, we say it has instincts. And if it is non-differentiable, we say it has will. So let's see this vehicle in action. Not gonna lie, I feel like vehicle 4 is where Braitenberg's sort of human-like terminology falls flat a little bit, and I just find it interesting to look at. So this is a sinusoidal function. And what I find really interesting about this one is that at some points you can really see the sine wave, but it also kind of just like bugs out, and it's fun to look at. Also show quadratic, so this is 4A with the differentiable functions. Yeah, this kind of is just like really speedy. And then for will, so with the non-differentiable functions, we should see a sort of, let's see if we can get it. Yeah, there's it's kind of hard to see, but there's a sort of like ticking-like behavior because the function is non-differentiable. And then my personal favorite is hyperbola. Sort of, okay, that one's not very interesting. But yeah. So these are Braitenberg vehicles. At the beginning of this talk, I asked you all, what do you think of when you think of artificial intelligence? And I brought up ChatGPT as an example. And the reason why a lot of people think of ChatGPT as intelligent is because it behaves like a human. But what I just showed you in this talk today is that people were asking these same questions 40 years ago and thinking about these same concepts with much simpler machines. So if there's one takeaway I want you to have from this talk today, I hope you have expanded your concept of what artificial intelligence could be. Thank you. Here's a QR code to the simulator. Here's a QR code to the simulator. Here's a link to the simulator. Here's my email. And last but not least, I want to give the biggest shout out to my advisor mentor, Professor Lucas Bang, who's here today. I think you're really cool, and I think it's really cool that you changed your last name to Bang just for this conference. Okay, thank you.